right, guys. So as you already know, your calculator doesn't have like algebraic things it can do, but what it can do, so what your calculator is not going to do today for you is actually get what the first derivative is in the sense of the actual expression, okay? But what it can do is if I give you a function and I say calculate the slope when x equals 5, it can do that. Because if I asked you guys to do this algebraically, you'd take your function, right? You'd find the derivative of it, and then you put the x value in. You guys agree? So what your calculator can do is it won't actually give you what the first derivative it is, but it will calculate it in its little brain, okay? And it'll put the number in for you and get the number out, okay? So that's what it will do for you. So I'm going to show you guys two different ways that your calculator can do this. I'm going to graph it first just because I like seeing the first derivative graph. It's kind of cool. But you don't have to do it if I'm just putting an x value into the first derivative and getting a value out. This would be the long process of doing it. But if you're using your calculator to find the max or min values, right, you do have to do it graphically. Just because, do you guys remember, if you're picturing the graphs right now in your head, if you were to, where do the max and mins happen? If you're looking at the first derivative, if you're looking at the first function, right, where the slope equals 0, right? So it's where the slope equals 0, which is where y equals 0, right? So that one we have to do graphically, okay? So I'm going to go, this first page is basically me writing down what's going to come out of my mouth. So I'm not going to read through this with you. My actions will do all this in the first example. Right, so that first page, if you forget the buttons, that first page tells you what the buttons are. So example 1 just says determine any max or min points on the function, right? F of x equals 2x to the power 4 minus 7x plus x minus 5 using the derivative function and the GDC. So GDC just stands for graphing device calculator, right? That's what IB uses, is GDC, okay? Round all calculated values to the nearest tenth if necessary. And the reason why I said using the derivative function is because could we, on our graphing calculator, get the max and mins without touching the derivative? Yes, obviously, right? We just calculate max min on the original function and we'd be done. So we're just going to change it up a little bit and use the derivative function to get our max min points, okay? So let's grab our calculator. So what we're going to do is graph the original function. So we all know how to do that. So go ahead and put your function in. So check to see if your plot's wrong. So just let me get in and I'll remember, because we haven't touched these guys for a while, right?
Yeah.
Well, I shouldn't say that. You guys should still be using them, right, when you do your regular stuff.
No, I'm a good
Right? So we put that in. So remember, guys, for everything to work properly, none of your plots should be on. So if any of those are highlighted, it'll kick you out. Go to your window. Right? I just have a standard window for right now. I'm not sure if it's good or not, but just make sure, just go zoom 6. Gives you a standard window. Zoom 0 gives you a window that tries to fit the graph, but I'm just going to, which never works. So I'm just going to look at a standard window. It's not low. Well, it looks okay. I can see almost everything except the bottom, so I'm just going to change my window a tiny bit and spread it out a tiny bit. So to do that, I don't need quite so much X's. I just want to see it a little bit better. I kind of basically want to zoom it in. So I'm going to go negative, say 6 to 6. The top looked good, but I needed more bottom. So let's try minus 15. Does that work good? Yeah, as long as I just want to see everything. All right, so that is my original graph. And I know that you guys could calculate max and min right now without touching the derivative. But I just kind of want to review because you guys need to know this stuff. right? This min right here, I know that the slope at that point is 0. I know the slope at this point is 0. And I know the slope at this point is 0. Okay? So I'm going to actually graph the derivative, first derivative graph. So if you go into y equals again, leave y1. So in y2, you're going to hit math. Math is right under the alpha button.
Yes.
Now if you go all, see number 8 there, end derivative?
Yeah.
That's the one you're going to touch, or go hit enter on. So hit enter on number 8. Okay.
I'm following the teacher.
Yeah. So remember, guys, this right here, d over d, guess what's going to go there?
Y.
Remember, what's your function in terms of?
Y.
No, it's definitely in terms of x,
Obviously.
right? It's y equals in terms of x.
Wait, so you're right.
So then all you're putting in that first little blinky spot there is an x, because it's d over dx. Yeah, the first blinky spot. Yep. So with this one, because it's the older operating system, we'll just put y1 there, because it'll just default to x. So guys, if you have the older operating system, what happens is it doesn't give you this nice screen. It just goes d and then d derivative and then a bracket. So you'll skip putting the x in. I'm pretty sure, I haven't used the older calculator for a while, I'm pretty sure though that it just automatically assumes it's in terms of x, so you don't have to tell it, but we'll soon find out. So then here, what are we trying to take the derivative of? What we put into y1. So we need y1 there. So you're going to put a y1, Laura. So where you find y1, so if you have the newer operating system, you can put them, you'll find them up here, but I know that not everybody has a newer operating system, so this is for sure where everybody can find it. You go vars over to y vars into function. That is the long way of finding it. Okay. If you look in your instructions up here, these instructions here are for the calculators that have the newer operating system. You can find it if you just go second trace. Sorry. And then you, oh sorry, alpha, I should say. Sorry, alpha trace, not second trace. So alpha trace, again, you will only have these operations if you have the new operating system. That's why I showed the other way, because that works for all the calculators. All right, so let's go back into the calculator. Oops. All right, so then down here, guys, so I'm not quite finished. There's one still little box that's left empty on the new operating system. So here, I want all the first derivative values. So if I want all the x or first derivative values, I'll say where x equals x. I always put it as x equals x, because then I can just go to my graph and find whichever one I want. So now it's going to take a second to graph the second derivative, but go ahead and graph. And it'll graph both. Yeah, exactly. So for this one, once my my first derivative graph shows up in here in a second, there they are. Right. So remember, we want where the slope equals 0. So the slope equals 0 here, here, and here. Okay. So does that make sense, guys? Can you see it? Because right here, this is the one value that I want. I want the x value where this minimum happens, which is that x-intercept. Right, where this max happens is that x-intercept. Where this min happens, right, is that x-intercept. So you guys can find your x-intercepts, right? So I'm going to go back doing it the way that you just do calculate 0.
Do you just close it to y1?
I think so with this
Because
one.
then it doesn't work.
All right, so
It doesn't work. The argument
okay, and then, okay, so with this one, then you might have to go. Let's see. So as you guys are waiting, go ahead.
Yes.
Yeah, if you have the older operating system, just give me 2 seconds. It's been so long since I've used it on there. Just kind of watch here, and then I'll figure that one out in a minute. So just watch, again, you can just watch up here. But I'll figure that out as soon as I'm done this one. All right, so this is why I said if you're going on here, guys, if they aren't nice values, as in not rational values, you can't get exact, right? So that is obviously a con to this, right? So we do want to find any max min points. So calculate 0, number 2. So notice up here, guys, this is important. You have 2 graphs. Up here tells you which one you're on. So we're on the Y1 graph, which is not our derivative graph. If you hit your arrow up, you'll see that it switches. So see how now I'm on my Y2? That's the one I want to be on. Whoops. And then right bound. I'm going through this quick because you guys, this isn't new for you. So then it does say round to the nearest tenth. So this one, remember, goes with this min. So I'm going to have a min. And I'll do my outputs in a second. So it does say nearest tenth, so 1.4, comma something.
-1.
Yep, sorry. Thank you. So I'm just going to do all my x values first. Right, so the next one I'm going to do is the max, since it's the next one in line there. Brian, if you're on your computer, just search derivative on the TI-83.
How do you have to? Oh, fine. This is like a game.
If you use your up arrows, up down arrows, hop the graphs.
Bound? What do you mean air bound?
You did left and right bound backwards. Yeah. So 0.07, so 0.1, since it said nearest 10. And then my last min. So I'm only showing you one of these, you guys, because realistically, if you have your graphing calculator, would you guys use the first derivative graph to find your max mins? No. So that's why I'm only doing this one once and not going to really focus on finding max and mins on the graphing calculator this way, because realistically, if you had it, you wouldn't do this. But I just thought I just wanted to show you the comparisons of the graph again, because it's cool. But other than that, like I said, you wouldn't probably do this if you had your calculator to find the max mins. All right, so my last one, 1.3.
Yep, I got that one.
So we can use, like I said, because we're just approximating. So now these x values go where to find my outputs? Into the original. No.
What do you mean no? It said 0 on the calculator.
Can we put the x value in on the graph?
Yeah, oh yeah, yep. Oh yeah, you definitely could do that as well now too. So I'll do one this way and then I'll do it on the graph. That's actually probably going to be faster. Pardon?
Do you want exact?
Here, I'll come over there. So you have to do 3 inputs. Okay, okay, so we missed one x. So I'm assuming this is saying in terms of x, and then we want all the x's. Did that work? Yeah. Perfect. Okay. So guys, thanks, Ryan, saving me that. I missed an x. So if you have the 83, how you're going to have to type it in is you still do y1. So after your bracket, it'll be y1 like normal, but first x basically goes that you're putting it in terms of x, and the last x means you want all the x's. So yeah, I forgot about one of the x's. So only if you have the TI-83 and not the new operating system, this is what has to go into your bracket. If you have the new operating system, you're ignoring me. Yeah. Oh yeah, that works as well. As long as yeah. Oh yeah, no, that's smart too. You have to put it separated by commas. So commas right under there. Yep. Mm-hmm. So did somebody else get negative 12.4?
Yep. Someone didn't know. I did. You're stupid.
So if you want to use your graph, guys, all you have to do is go back to here, hit trace. I'm on Y1 graph. I don't want the Y1 graph. I want the Y2 graph. It's important that you always are on the proper graph. And then you literally can just type in 0.1. Enter. There's my output. So 0.4.
Yep.
And then now I can put in 1.3. So just hit trace. As long as you have numbers, guys, on the bottom, you can put whatever values you want in for X and Y.
Oh. I got negative 5.02.
That's on the derivative graph, not
Oh,
the.
thank you. Yes.
Oh, we were right.
Yeah, you're good.
Yeah, I'm good. Of course, I never guessed myself. Never. I'm always right.
So try that again.
I'm always right.
Yes.
Oh, never.
Is that better?
Yes, it is better. Yep.
So negative 5.0.
Yep.
When you find the actual it's because you can't do it on the derivative.
Pardon?
You have to do it on the original function.
Yeah, down or up arrow flips your graphs.
Like when you find the zero, you can put straight down.
Right.
Say that again, sir?
Like we put like if you find the zero, like 0.97.
Yeah,
Zero
like negative 5.0.
you just hit the down arrow. That's the exact point. Just
Yeah.
Boom it.
exact value.
Just
It
bang it.
also says like still like
What are you trying to calculate? The x-intercepts?
yeah.
Like when you no, it's when you zero.
Yeah.
And then I almost put it over.
Yeah. Oh, I see. Once you actually have that one.
Yeah.
I see. Yes. That's a good idea. Sorry, I wasn't following
Pops.
what you were doing. Like what calculation you were doing. Yep.
How strong your legs and popping all these backpacks.
Yeah.
Just do hurdles every single day. Have you ever done that before?
What?
Like their backpacks in class and all the teachers stuff.
Oh, this class is great. My block 3 is Thursday. But there's quite a few in this one too, but it's all good. All right, guys. So example 2. So this is more, even though I've done some nice easier functions where you might argue with me and say, Ms. Calvert, might be faster for me to just do a paper pencil, right? Would you guys agree for this one? It's probably maybe easier to do a paper and pencil?
Yep.
Yeah, absolutely. That's why you would probably not use this, okay? I just wanted to do some easy ones, but something like, say, this one, right?
ln x sine x tan x. Oh, okay, that's
Right, so something like this,
take a while.
there will be, guys, you will be given some equations that's actually beyond what you can do paper pencil, right? That's when you would definitely use your graphing calculator, okay? I won't, like I said, that won't, if it shows up, it would only show up on a assignment, and I would instruct you to use the graphing calculator, okay? Because something like this is beyond our syllabus for algebra, okay? But it's definitely okay to use on our calculator. All right, so before we get to that one, but like I said, I agree with you that example 2, it's probably going to take longer to type it into the calculator. But this one, I'm gonna show you now both ways that you can get a value for x. So this is the long way, is putting it in this way.
Okay, man. I absolutely got rid of it. How do you know? Cool.
Oh my.
Yeah. Good. Kiki.
Okay, they're
Yeah, they're unhealthy and bad for you.
So the nice thing is I don't have to retype all this. The only one I have to retype is the top one. Just want to make sure that I put it in. So believe it or not, guys, this is the longer way of doing it. So go ahead, hit graph. So there's my original. I just like doing it graphically because it's kind of cool to see the derivative graph. But in a question like this, you probably wouldn't do it this way. And remember, does it make sense that if my original is a cubic, my derivative is going to be a quadratic? It should. All right, so then all I have to do is go hit trace. It's just because I want numbers on the bottom. You could also hit second trace and go calculate value. That would work as well. But now here I do want, right, the slope or gradient, right, where x equals 1. So which graph do I need to be on? The blue one or the red one? The red one, because I do want the derivative, right, at x equals 1. So then as long as you have numbers on the bottom here, just hit equals 1. Hit enter. Just hit, are you on the derivative graph?
Yeah.
Yeah, so just hit 1. Yep. So remember, guys, as long as you have numbers here, you can put whatever value you want in for x at any point in time. The other way that I showed you guys in class is doing it this way, where you go second, trace, number 1.
Yeah.
Right? That also does it. Okay. But to me, that just takes, now I'm on the wrong graph, so I can just hit my arrow down, and now I'm on the right graph. Just hit trace and put my number in. Because as long as you have numbers on the bottom, you can type a number in. So therefore, right, your gradient. So are we done the question?
No.
Nope. So we know that the slope is 7. So I do need to find out what my y is. But the nice thing is everything's on the calculator, so I can literally just go back up to the other graph. Right? It doesn't equal 0, it equals 6. So remember, guys, you put 1 in to my original graph to get my ordered pair, because I need my x and y, because here I'm writing the equation of a tangent. Right? So my point is 1, 6. My slope is 7, because remember I got my slope by putting 1 into my derivative graph. So now you can write the equation. So did you guys get -1 for B?
So cool. Wow. It's a new hair.
It's something alright.
Confident.
Right. So getting a derivative value, guys, like I said, it's just a nice tool for you guys to see or have, especially to check work now. So the last one I just wanted to show you before you guys go, and
go off.
I'm down to go.
so
Can you say that word?
So this one, term the equation of the tangent line to the function y equals ln x sine x tan x minus x at the point x equals 4.
There's no way you just did that. That was crazy.
Linux. Power.
Oh, it's got the minus x.
You should be up.
Yeah, how do you mode? Oh, I'm in Meridian. Whoa. Is that what you got? I got a phone for you. Yeah, me too. Look at this guy though. I'm actually just gonna table this.
So it's kind of cool to see some weird graphs.
Is it cool or I think it's more stressful.
Oh, I didn't check my mode.
Oh,
I
got
feel a
it.
little stressful with this graph, not gonna lie.
My TA84 looks excellent. My TA84 looks excellent. It's colorful. You like it so much? I'm more old school. But you know.
So I'm assuming it's in radians because it's graphing nice.
It is.
Yeah, that's right.
That is radians, good.
Yep, yep.
So
It just keeps going blah blah blah.
and again, will you be graphing these? Absolutely not. Paper, pencil. But it's kind of cool to see. So then all we have to do is hit trace and go to my derivative graph. So hit my arrow down and hit x equals 4. So my slope is negative 4.72. And remember, it does say, because we can't get the exact value because it is an irrational answer. It's not what you got.
We'll find out in 1 second.
You got negative 4.72?
I
Okay.
got that
So you're wrong. Are you in the right mode?
No, I put -1 instead of -x.
Oh, did you go -1 instead of -x like Aiden did? Yeah. For you to get exactly the same answer, it had to be exactly the same mistake. Yeah.
Wait, that's not what I wanted.
Because that's what slope is, right? Is any time in the whole class, so every time we're writing the equation, the first derivative is always your gradient equation. Always, always, always. So then we do need the ordered pair. So our ordered pair was 4 comma. So remember, all I can do is just, guys, hit my up arrow, go back to my other graph. See, there's my ordered pair for x equals 4 in my original. And we are doing everything nearest hundredth. You don't have to do more than that. Because like I said, we're just approximating. So negative 5.21. I could be on the IB exam, yeah. But even guys, I do, like I said, even if you weren't in IB, if you're just in a regular calculus class right now, I still do this lesson. Just because it now gives you a tool that you can use to check all your stuff while you're reviewing, and because normally we would have a final exam, right? But remember, we still could have a final for those ones that want to write it, right? It can do a replacement if you wanted to.
And it's no fault.
It's no fault.
Is it actually?
Yeah, it's no fault. It's just if it counts your mark, you can use it.
I'll do it to get a 40. Just like in
You guys would be surprised
I would be very surprised.
to get, that bad of a mark. Because again, guys, do you guys not agree we've been doing the same thing over and over and over again?
We really haven't calculated.
Yeah, you should be getting good at it.
Yeah.
The only thing I think is limits. The
You
limit
guys are
stuff
funny.
is
You guys do awesome on all your stuff, and you like pretend that you don't.
Limits is the only thing that.
Yeah,
limits.
I
The,
agree.
the derivative stuff is like all pretty like repetitive. It's just the limits like the so.
I agree. The limit stuff, there's definitely some things that we did not continue to do all the time, like the limits, for sure.
Wow, imagine rounding to your full equation, not waiting until the end. Awesome try, right? You luckily got the same thing as me.
I luckily.
Oh, really, Austin? You do it properly. Oh, that's the generous 100. Fudge. I was gonna flame you for putting the juice. So you
So-
don't have the same as me because you.
Can you guys think of a way to do second derivative?
You put the.
Derivative, there's the derivative.
Yeah. Wait, you put X squared?
No. Exactly. So if you do, because I gave you a couple questions down below for second derivative. If you do second derivative, all you're going to do is in the y equals, you add another one.
Another one.
Yep. So here you would just do another one. So you go math,
Well, then you do Y.
number 8. Exactly. Oh crap, that's not where I wanted it.
Oh,
Oh, rip.
Just go delete.
Anyway, you guys will,
Yeah.
whatever. I'll just pretend to put something else in.
If you're pretending to do my actual.
That's what he had to sign it.
Yeah. No.
Oh no, this one isn't in the assignment.
Yeah, I'm just making one up. So I just want to show you guys the next step. So it literally would be just this again. Instead of y1, it'll be y2. You'll have 3 graphs. Could you do 4? Yeah, you could do as many as you wanted. Okay. So that one though, guys, does have to be on this screen, right? If you're doing more than one derivative, you do have to graph it. If you wanted just to find the slope and not graph it, because is it a little bit time consuming? It is. So just to show you guys, if you wanted to just get this negative 4.72 and not have to wait for the graph and everything, guys, all you could do, no, so because here you're still waiting for the graph. If you go to your main screen and just hit math, number 8, just like we did in the graphing, you can do it all right there. So if you just go X, put your function in,
Oh. And then X equals what?
Yeah, so you put your name wrong.
4. Oh, wait. Oh, you should put it in.
I'm just putting this one in again, just so you guys can see that I'm going to get the same answer.
Or can we put Y1 in? Like in there?
In here,
Yeah, can we put Y1 in?
no, because then it's going to go to your table because you want to do it all here. You can try it. I don't think that would work.
It would only work if it's actually in your Y1 spot on your graphics.
It is in
Oh, it's still in your Y1? Try it. I've never done that.
bars.
And instead here though now, guys, I want to say actually where X equals
4.
4.
I got it.
Yeah. So as long as it was still in your Y1.
Discover. We had example 4.
Oh. Oh, right. I did change it this morning. So I got it. So let's go to your guys' example 4. Did I? Because I'm like, I changed it this morning. That's right. Did I put it here, hopefully? I'll grab it because I just fixed it this morning.
If it is, yeah, I'm gonna get my notes.
Sorry, guys. I thought I put the updated one because, like I said, I started playing around this morning with more of them.
No, it's fine. You're not upset. I still didn't understand it.
All I had to look so little.
I heard
You just always hear the
I heard Austin looks like a textbook, but that's okay.
This is
Not a
That's like an animal out of Zimbabwe. Huh? I don't know. Aiden used the Aiden does. This is
Pardon? You go math, number 8. And then to get your Y1, it's ours.
I swear they could also just be not say anything and I'd be like, how did you not know?
So you guys can go ahead and do your first question while I slowly find the
It's
right.
like my grandpa when I'm leaving.
Is that how you figure out if you're in the middle? Austin. You don't have
He does have.
You can tell he's thinking something.
He was about to be.
Sorry, this is where social fair. No, you passed, he failed.
I failed. Oh, it's a dog in the well,
No.
it's like 20%.
I do not have the biggest
Second biggest.
Second, I guess Austin is in this class too.
No, you can say third biggest.
Oh yeah, sorry, yes sir.
That's-
Three. Devon doesn't have
Then maybe me.
Then, no, not then.
Devon just has multiple chances. This isn't that question. What happened?
He goes,
I don't know how you go.
Austin number one, number two, three.
I'm second.
So guys, your example 4. You guys all have it, guys.
Sure. I'll take it, I guess.
Come on, Aiden. Guys, come on. Did you put your example 4 in? You can do it without me. You don't have to wait.
Oh, I thought we were doing the assignment.
waiting. You don't have to wait.
I thought we were doing the assignment.
Well, you can do that as well.
Hey, sorry. I didn't mean to hurt you. Just heard
How do you be over here? I will eventually.
math, you go down to 8.
It's on the page.
Yeah, if you put
Oh, I
8.
didn't. Yeah, I will get you a couple of minutes. You ring me up.
It's 290. It's 94. For second derivative, do you put y2?
Yeah.
Y comma Just right. That's the graph. Murky water.
Murky water. Okay. Oh, did I get something? Kids are done for- No, dude, I did not pay attention to this.
Covered. I keep misclicking. There's so many lines. Buggers.
I think Miss Calvert is the best of us and the worst of us. Thus, she's our best friend.
Miss Calvert, Miss Calvert, you know what? Even on the exam, I just don't even care anymore. I'm not using the calculator. It takes too much effort. And it's wasted.
You will have to, because if one of these questions come up on the IB exam, on the calculator part,
It's like 3.
it's written, so you have to use this. That it'll be beyond any algebra you can do.
And if you think you did it right, you actually did it.
I mean, I'll do it, but I just.
Yeah, and again, it's probably not going to show up. Like I said, there could be a question, but like I said, if a derivative question shows up, like I said, on the calculator exam, they will write it so you can't do it algebraically.
Is the calculator exam multiple choice or just short answer?
There's never no multiple choice on any of your other exams. Oh yeah. Do you say are we going to prepare?
No, she's just gonna throw you in there.
Yeah, you're just going to write it.
I mean,
Yes.
When by chance we do it.
Probably. Well, I will formally start. You guys can start on your own. You have lots of stuff. Like I'll give you guys some more material. But we will start probably 2 weeks formally before. No, 2 weeks before. But I'll start giving you guys stuff if you want to start looking at
that
things.
seems great because in this case that, oh, the ID math, they send us, I don't, yeah. I just really hope it doesn't.
Oh my God, I got 15.
All right, guys. So what did you get for 5? Anybody do it yet?
I'm trying to grasp. I'm trying to get the window to fit.
They look
It takes
really
so
weird.
long.
Does it matter if the window fits?
No.
As long as you have x equals 5, who cares about the window?
But like, isn't it supposed to be on the like the second derivative graph?
Yeah.
'Cause I can't see it properly. So
But it doesn't matter as long as you have in your window, because you're just wanting to see where x equals 5, right?
130?
So you don't need to actually see anything as long as your window covers 5.
Are we looking at the second thing that I got?
Or where's your second derivative? In which line?
I don't even know.
Well, no, look at here. You do know.
The third one?
Just showing you.
The third one.
So when you have y1, that's your what? First derivative, right? So the y1 is your original, y2 is your first derivative, and y3 is your second derivative. Well, second derivative tells you acceleration, right? First, which we haven't really talked about yet.
physics acceleration?
Well, if you guys like really think about it, I mean, we graph
I don't want to think about it.
Yeah, you should.
I'm sorry, please go ahead.
It's really not like out there.
Bryce is going to explain it to Jesus in theory.
You got like displacement, speed, and like acceleration. That's the order of the graph. And so the graph is
When
right.
I'm checking, don't touch me.
Let me tell you this.
That's straight peace.
After physics ended, I got rid of it all.
Hey, don't
I created more space in my brain for other stuff.
It is 294.
Oh.
No, that also helps. That helps with anything.
So did anybody else that's still focusing got 294?
Yes, ma'am. How? The box says how.
I just needed the
This is. Oh, I didn't put. Abort mission, abort. Abort mission. I didn't even put the equation in. Actually, that's the equation. I put look everywhere there.
And remember, that's not your slope, right? Because we're at the second derivative. So what you guys can do is I just made up a few questions. I added a couple more this morning as I was playing around. The sheet that you guys have obviously is the one that I literally finished 20 minutes before class. And I'll do an answer key and put it on OneNote. I'll do them right now as you guys are doing them. So this should not take you the rest of the class, but if it does, that's fine. But if you finish early, you can make sure your Chapter 8 assignments are done and handed in. There's still some of you that are missing other summative assignments. Please get those in sooner than later. Just look on OneNote, on PowerSchool. You can see which ones you're missing because there's some other cumulative reviews that I need, right, from some of you. So if I don't get them this week, then I'm coming around next week and taking whatever you have finished, right? So if it's a blank, that's fine. You'll get a 0. If it's half done, whatever it may be. So then I can finish those, right? Those aren't the IAs. Those are just, most people are finished them, but